Time, a phenomenon that we cannot touch, yet we feel its grip on every waking moment. For millennia, humanity has been obsessed with the idea of bending this intangible law, of traveling beyond the barriers of now into what came before and what lies ahead. This dream has echoed through our stories, ancient and modern. H.G. Wells envisioned machines that would hop across centuries, and cultural landmarks like Back to the Future gave us characters who scrambled to rewrite their destinies. Films like Interstellar go further, teasing audiences with realistic glimpses of how time could warp under extreme conditions. But what if it wasn't just fiction? What if time travel, in some sense, is already part of our reality? Our understanding of time forever changed in 1905 when Albert Einstein introduced the theory of relativity. He fundamentally altered how we view the universe and time itself. Einstein revealed that time is not universal. It can stretch, slow down, or speed up, depending on extreme factors like velocity or gravity. This phenomenon, known as time dilation, tells us that clocks on Earth actually tick slightly faster than clocks aboard satellites in orbit. In 1971, scientists conducted the Hafele-Keating experiment using atomic clocks on jets traveling east and west around the world. The result? The clocks aboard the planes fell slightly out of sync with those left behind on the ground, proving time travel happens every day, albeit on a microscopic scale. Yet some theories imagine possibilities far grander than mere time dilation. Take wormholes. Hypothesize shortcuts through space-time, where one end of the tunnel could lead to another place or another time. Astrophysicist Kip Thorne, whose equations were central to the visuals in Interstellar, proposed that wormholes might connect different timelines. However, the energy required to stabilize such a portal is astronomical, far beyond anything humans could harness today. Another tantalizing concept comes from cosmic strings, ultra-dense filaments that warp space and time to extreme degrees. On paper, rotating around an object as massive as a cosmic string might fling you backward into past moments, but these theories stumble on their own logistical roadblocks. If attempts to travel back in time create paradoxes, such as the infamous grandfather paradox, destroying your own past, the consequences could unravel the very fabric of causality. What about time travel at the quantum level? Quantum physics presents bizarre loopholes where classical rules don't apply. Theoretical closed, time-like curves, CTCs, describe trajectories in space-time where an object loops backward before reaching its starting point. Scientists like David Deutsch and Seth Lloyd speculate that quantum systems might resolve paradoxes by creating alternate branches or timelines, essentially invoking the idea of the multiverse. Some critics worry collisions at the LHC could form miniature black holes capable of swallowing up the timeline itself, or even opening gateways to other dimensions. Scientists, however, assure the public that any black hole formed would decay instantly and pose no threat. Time travel remains an enigma. Scientists like Stephen Hawking have pondered these questions with skepticism, famously hosting a time traveler's party where only guests from the future would be welcome. No one showed up. Here's the truth. Time travel, in a sense, already happens. Astronauts aboard the International Space Station age slightly slower compared to us here on Earth due to the effects of relativity. Experiments with atomic clocks aboard airplanes confirm the tiniest fluctuations in time. We are all time travelers, moving forward at 24 hours per day. But what would it mean to leap through time, to reshape history, or to glimpse tomorrow's world today? Perhaps time travel will remain confined to theory, or perhaps quantum computing and exotic matter will someday unlock possibilities we've only dared imagine. But here's the question we must ask ourselves. Are we already living in someone else's past?